let's begin with question number 1 of this new paper, KP2 advanced. Okay, let's move it to whiteboard, please, and read it and begin. So write down the inverse of the matrix 4376 and use this to solve the simultaneous equation below. If you notice how it links is later, I'll show, but you can see the 4, 3, 7, 6 in order like that. Okay. All right, so no risk. Let's try to figure out the inverse first. So the inverse of a matrix, so I put it like this. We use a notation style. If A, matrix A equals to A, B, C, D, like that. So the inverse of a matrix has the formula that 1 over AD minus BC. And then the corner here we switch place, DA like that. Negative B, negative C. Okay, these two switch place. And these two, we turn it into a negative of each. Okay, that means in this instance, A will be 4, B 3, C 7, and D 6. Okay. So let's try to compute the inverse, please. So the inverse of this matrix would be 1 over AD minus BC, means 4 times 6 minus 3 times 7 BC. And then in the bracket, we switch the two places. So 6, 4, negative 3, and negative 7. Okay, when we simplify this, please take note 24 minus 21, you can use a calculator. It's 3, and then this is 6, negative 3, negative 7, and 4. So we can leave it like this first as the inverse matrix. Okay, now generally also, how do we solve an equation? Must understand that when we have an equation ax plus by, okay, and then this is cx plus dy, abcd, so equals to E and F. When we turn this into a matrix equation, okay, when we use matrix, that means basically they're trying to create a formula, like an array of numbers for the equation which we can prove algebraically, then generalize accordingly. So A, B, C, D, see the A and C are both belong to X. So that is why we write it as in that order X and Y. And then E, F are the two constants. So if you look at the given equation, it needs a little bit of tweaking to be written in this form. 4x plus 3y equals to negative 7. And then 7x plus 6y equals to negative 16. Okay, please take note 4x plus 3y is negative 7. 7x plus 6y is negative 16. And then now let's try to write the equation, please. So 4, 3, 7, 6, and then xy. This what happens. So negative 17, negative 7 and negative 16, like that. So the idea goes that when you want to find the x and y in this matrix form now, you multiply by this plus inverse. Or the inverse of the 4376, which is the right matrix up here. Just copy the whole thing, 103 like that. 6, negative 3, negative 7, and 4. Then the green one would be negative 7 and negative 16. Okay, please take note. Then you may wonder whether to times the 103 inside and then multiply. Actually, technically, it doesn't make any difference because imagine each of 3 got 1 over 3. But if it times, just the over 3 is there. So best is to keep it aside first. So we leave the 1 over 3 outside. We just multiply the inside. So how do we multiply a matrix? You can remember. So to multiply a matrix, what we do is we just go for the row and then match it with the column like that. Meaning that this is row multiplied by column. 6 times negative 7 plus negative 3. Then with the second one, you match second term, negative 16 with that. Then let's go for the one below. So negative 7 and 4 multiplied this way. So negative 7, negative 7 multiplied by negative 7, and plus 4 with negative 16. So let's simplify in the bracket close. So this becomes, aha, tell me this is 1/3. Then let's use the calculator, please. 6 times -7 plus -3 times -16. 6, this one. -7 times -7 plus 4 times -16. -15. So this would be xy. Please take note. Just pulling it up from here, writing it closer. Then finally, we times the 1/3. 1/3 of 6 goes inside like a constant. -15 multiplied. And we arrive at the answer, which is 2 and -5. That means in short, we should write the value of x as 2 and y as -5. Sorry, -5. Thank you.